Okay, welcome to this next lesson on creating the parts for the toe ball assembly. This lesson is going to be looking at this mild steel hex nut down the bottom here. You can see from the drawing given to us that there's no sizes at all. So the only information we can get is that there's a thread going through the middle here, which must be equal to the same thread. Now remember, this is not an M18 thread, we've actually changed this to an M16 by 2. Other than that, there's no other information. So once again, we need to consult our representations chart. So if I'll just skip down a couple of slides, down to slide 48. And on slide 48, we can see here that there's a basically a chart that gives us all of the dimensions required depending on the thread size. So we can see here's our thread size of M16 by 2. And we need to find out the standard sizes for the thickness of the nut, which is K, and then we know that a nut is based on a hexagonal shape, so we can have either its diameter or the length of one side. So we might go for length of one side, which is B. So we'll scroll down, we can see length of one side is 14 and K, being its thickness, is 13. So remember that, 14 and 13. Let's go to Creo and let's start creating this actual nut. So file new, of course. We'll call it hex nut, and OK, and OK. Turn your planes on as usual, and at this point I'm going to select perhaps the horizontal plane and sketch, and then rather than trying to draw a hexagon, which I could do, I can use this palette up here. Click on the palette icon, scroll down to find a hexagon, which is here, and then simply drag that across to your drawing and let it go. This white anchor point in the middle here can be used to anchor that onto or snap onto something. Hit close, and then yes. And the last thing to do is just to edit the size. So I think back to memory, that was supposed to be 14 with the length of the side, and enter. And you can see that a hexagon's sort of been created. So the hexagon is complete. All the dimensions and all of the constraints are locked, so we can accept that. Extrude it to a thickness of 13 millimeters. OK to that. And then the last thing to do is to put that hole through the center. Now you'll soon see why I placed the center of the hexagon over the center of these axes. OK, go to the hole command, and under placement we need to place the object. So we click that top surface. These green handles here need to be locked onto some edges or onto some planes. Now if I lock this onto the edge, perhaps you can see it gives me 90 degrees between the edge and that plane, and likewise. Unfortunately though, we don't really have any dimension to tell us the distance from this edge through here to the center. So rather than locking the edges onto these, the handles onto these edges, I'm actually going to lock these handles and grab it and wait hopefully for these planes to highlight. One there, and grab the other one and lock it onto this other plane. Now what we've got, if I just spin it around, zoom in a bit, is we've got distances for the center away from these planes. So if we make these distances 0, it's going to bring the hole to the center of our object. A little bit confusing sometimes, you've got to rotate those around to get the sizes right. Now the hole's in the center, and now it's just a matter of selecting the correct size hole and so on from up the top here. So with that information there, we'll go to, this is a standard hole. We're going to have a hole with a thread in it, so we're going to be creating this one. Scroll along here, we can see there's all different functionality about tapered and so on, but generally speaking we're going to be creating a metric, or if you like an ISO thread. And you can see here this box, next box along, is saying, well, from M1 by 2.25 we can then scroll through and go down to find out M16 by 2. And the rest of it should be pretty right. The depth doesn't really matter, it's just going all the way through, and we don't need to counterbore, we don't need to countersink, so we can just accept. And you can see here now that we've got the correct representation of the thread on the inside as well. Okay, the last thing to do is to then create a chamfer off the top of the actual nut. We go back to our PowerPoint. We can see here that the top of the nut is actually, the top of the nut's actually chamfered off. there's no real particular sizes about that, so it's going to be a little bit of poetic license. So we'll just go back to our Creo, hopefully, there we go. And I need to choose a work plane to draw a sketch on so I can revolve a chamfer around. You can't use the chamfer tool like you would normally do, because the chamfer will only create a chamfer on edge and it won't actually create it in a circular motion, so that's no good to us. So let's choose this work plane here that's passing from the flat of this side to the flat of this side, not from diagonals, but from flat to flat. It's very important. Let's sketch onto there. Let's click on some references. Close those references, and now simply what I'm going to do is use my line tools to actually draw myself what this chamfer might look like. Like I said, there's no particular set sizes. If we have a look there, it's probably a little bit close to that hole there, so I might just edit that. So go back to 90 degrees. I might pull that back a bit if I can. Might pull this up a little bit, might be a bit low. And before I then accept that, I'm going to put a center line down through the middle as well. So make sure you use the center line, because remember that for this sketch to revolve it has to have a center line. Okay, back to select. It's filling in. Good, there's no red dots. You can accept that. And go to your revolve tool. And we need to choose subtract. And okay, there's an issue here in that it's because this triangle is actually revolving around, it actually doesn't extend far enough, so I'm going to have to just edit that sketch. I'll just accept that. Okay, it doesn't like that, it's something in the maths, so that's okay. We'll go back to the sketch. I'll just edit this sketch. Just going to put in some extra lines here to subtract the material. I might even bring it down like so. Get rid of the lines in the middle here. Select, looks okay. And okay, looking, still not right. Still need to extend that down further. Okay, so back to sketch. And then we need to actually extend this line down here, so live and learn. Needs to be parallel and then join. That's looking better. It's probably still a bit big actually, we could have brought that point further back, but you get the general idea. So that chamfer would normally be applied to both sides of that nut, and then we can obviously save that. Okay, there you go.